This week we're going to talk about energy, what it is and why it's important and how it's related to chemical reactions. So energy is the capacity to do work, and basically it puts matter into motion. And since we are all made up of matter and elements and compounds are matter, then we all need to have energy. We measure energy by its effect on matter. So the greater the work, the greater the energy. So basically work is going to represent that effect that's on matter. There are two forms of energy, kinetic energy and potential energy. Think about this in terms of the bicyclist here, okay? When the bicyclist is still at the top of this hill, he is full of potential energy. Potential energy is stored energy, right? When he starts to go down the hill, that energy now becomes kinetic energy or energy in action. So kinetic energy will move things, whereas potential energy is like this inactive or stored up energy where there's no work being taken place. So once potential energy is released, then it will become kinetic energy. We also put energy into different categories based on where it comes from. So chemical energy refers to the energy that's stored in the bonds of chemical substances. So when you have H2O, and we talked about how the hydrogens and oxygens are bonded together, that is chemical energy, the energy in those bonds. Electrical energy is caused by the movement of charged particles. So ions, nerve impulses, those are examples of electrical energy. When you get electricity from electrical energy, it's a movement of ions or charged particles from one spot to another spot. Mechanical energy refers to energy directly involved in moving matter, so like moving your bones, moving around. And then radiant energy is energy that travels in waves. So this would include light energy, UV energy, anything on the electromagnetic spectrum. And for our bodies, that would include sight would be an example of using radiant energy. Vitamin D production would be an example of using radiant energy. So how is energy specifically related to chemistry? Well, in order for chemical reactions to take place, we have to have, first of all, a certain amount of starting energy, and then we also have reactions that are going to absorb energy or release energy depending on what's happening. So we put chemical energy into basically two categories, endothermic and exothermic. Endothermic reactions are going to be those reactions that absorb energy as a product is made. So photosynthesis is a great example of an endothermic reaction. We're taking the energy from the sun, the plant's absorbing it in order to make its product, which eventually is going to be a sugar. Now, some chemical reactions release energy, and so heat ends up being produced as the product is made, and these are called exothermic reactions. So when we burn wood, we're releasing energy, we're releasing heat, and so that's how we know that that's an exothermic reaction. Now, if you look at kind of the difference, this chart shows the difference between the two. So an endothermic is a chemical reaction where energy is absorbed. Exothermic is when energy is released, typically in the form of heat. The origins of the energy, endothermic, that origin of energy is going to come from the environment, and an exothermic reaction is going to come within the system or within the elements or compounds in the reaction. In terms of the amount of potential energy, endothermic reactions have a lower amount of potential energy or stored energy, and you can see that on the graph here. There's a lower amount of stored energy in this than there is in an exothermic reaction. And there's higher amounts of stored energy than in the products of an exothermic reaction versus the endothermic reaction. Higher in the reactants of an exothermic reaction. Production is non-spontaneous versus spontaneous. These two things aren't anything that you need to worry about for our purposes. But a really good way to kind of tell the difference between the two is looking at temperature. So in an endothermic reaction, the temperature will decrease. And in an exothermic reaction, because heat's being released, the temperature will increase. And some examples, again, photosynthesis. Typically any kind of synthesis reaction in general is going to be an endothermic reaction, and an exothermic reaction will be decomposition reactions. A burning of a match is a great example of an exothermic reaction, again, because you're creating something that releases heat. Here's another nice graphic, I think, that kind of visually shows, an exothermic reaction, heat is going to be released from the environment, versus an endothermic reaction where heat is going to get absorbed into the environment. So that's kind of how you can tell the difference between the two.